China isn't the only country that knows how to build creatively. Workers around the world, like in America and Europe, have come up with fascinating new construction techniques that seemingly defy the laws of physics. From 3D printed homes to windows that grow algae for heat and concrete that heals itself, these engineering marvels are on another level. Inflatable concrete. Developed by Italy's Dante Bini, inflatable concrete structures are essentially buildings built using air. First, the builders put down an inflatable canvas shaped like a dome or any other form needed. Then, this canvas is filled with air, creating the rough outline of the desired structure. The experts then cover it with steel bars, creating a grid held up by the inflated dome. After that, concrete is poured all over the surface, covering it entirely. Now, it's just a matter of waiting for the concrete to dry out, and the job is done. The inflatable inner part can be removed, leaving behind a freestanding structure that's surprisingly robust. This technology is being used all over the world to create quick shelters, whether that be for temporary use or for quick responses to emergencies. The whole process is surprisingly fast and requires less labor than building a normal structure out of concrete. Best of all, the same inflatable dome can be reused over and over again. It sure is a unique way to build, much like this next technique that's revolutionizing bridge construction. Bridge launching. Bridge launching, a construction method developed by Marco Rossignoli from Italy, is one of the coolest ways to build a bridge you will ever see. The sections of the bridge are first hauled onto the site. These sections are pre-built in a factory and are designed to fit together perfectly. Once all the parts are on site, the assembly begins. The bridge is put together, but instead of being assembled between the piers, the process is done on a nearby plot of land. Next, a launching nose is installed over the span where the bridge is to be placed. This metal framework, made of girders, will help provide support during the next phase. Then, the real magic begins. Powerful machines weighing tons lift up the bridge in its entirety. The structure is then placed on special bearings that are covered in low-friction materials. This will help the bridge slide along without bending. These specialized machines, alongside hydraulic jacks, then slide the bridge into place, pushing it slowly over the bearings until it is in position. It is mind-boggling to see such a massive structure being moved through thin air. Once the bridge is in place, the framework is removed, and the structure is secured in place, completing the installation. While smaller bridges can be installed in their entirety through this method, for larger bridges, the process tends to be incremental, meaning large pieces of the bridge are pushed forward, as other pieces are attached in the back at set increments, until the entire bridge is assembled. The whole process requires complete coordination, since one mistake or misalignment can mean the entire bridge goes down or gets damaged. But at the same time, this method of bridge installation is much faster than the standard method, where the bridge is built over the gap segment by segment. Bridge launching can turn weeks' worth of work into just a matter of a few days. Ram earth construction. Ram earth construction is an ancient way to speed up the process of building a home, dating back to the Neolithic era. First, the workers create a mold in the shape of the desired structure. Then, they put soil into the mold, which is then stamped down using a machine or by hand. This removes the air from between the soil particles, making it more solid. The soil is added layer by layer, with each layer being stomped individually. This ensures that the soil gets compacted as much as possible, which will improve the stability and toughness of the structure overall. Once the entire wall has been created in a similar manner, the surrounding mold is removed. And what comes out is fascinating. The freestanding soil structure is extremely durable. It can stand for years without a problem. At the same time, it provides excellent insulation, keeping in heat during winter and maintaining a cool temperature during summer. At the same time, artists have created some marvelous structures using the same technique by combining different colored soils. Kinetic architecture. Kinetic architecture is a type of construction technique that not only looks cool, but is also super practical. Buildings that utilize this technique have sections or parts that can be moved around. This is done for a variety of reasons, sometimes to expand the available shape, and in other cases, to protect against the elements. For instance, there is the Burke Breeze Soleil placed atop the Milwaukee Art Museum. This massive structure spreads open like the wings of a bird to provide shade for the people underneath, while also acting as a shield, protecting the museum from storms. But that is only one application of kinetic architecture. There are even more fascinating examples found around the world. For instance, the One Ocean Pavilion is a building with moving facades that can create different patterns. The Bund Finance Center has a similar feature where the facades move in complex patterns, opening up and closing off sections of the building to accommodate more people. Another fascinating example is the Al-Bahar Tower, which has an umbrella-like structure covering it that opens and closes to prevent glare and heat from the sun from entering inside. The coolest of all, however, has to be the Sharifi Ha House, which has rooms that rotate to open up more interior space. The kinetic architecture construction method is still a developing one, and what we are seeing is only the beginning. As technology advances, who knows what new applications we will get to see of this concept? Slipform construction. American architect James McDonald developed a much faster way of building structures using a technology called slipform construction. Here is how it works. They first build a framework platform that basically contains the mold of what the planned structure will look like. Then, concrete is poured into the mold continuously. At the same time, the entire formwork crawls up the building. The concrete hardens, creating a new foothold, and the formwork keeps on crawling up. It is like a living machine building its own path as it moves up. It is an incredibly fast method of constructing tall structures, taking only a few hours to a couple of days to finish up. Still, there are some limitations to this construction method. First, the mold cannot be customized mid-construction, so it can only be used to create structures with repetitive layouts. And secondly, the entire structure is made in a single continuous pour, limiting how high it can be built. And that is where another similar construction method comes into play, called climbing formwork. This system works in a similar manner, but instead of pouring the cement continuously, the formwork moves up one story at a time. This allows for more control over the structure's layout and allows for more complex floor plans. While not as fast as slipform construction, this method is still incredibly efficient at creating skyscrapers in a short amount of time, with minimal waste and noise. In both cases, the framework moves up the building using hydraulics. The entire frame is pushed by a bunch of hydraulic arms that work in conjunction, like a caterpillar climbing with its many legs. Light-emitting concrete. Light-emitting concrete is an emerging tech out of Germany and Hungary that's not just practical, but also extremely beautiful to look at. This new kind of cement is developed to contain phosphorescent qualities, allowing it to glow in the dark. The phosphorescent material contained in the cement absorbs light during the day, and when it is night, it releases that stored-up light, creating a beautiful glow. Experts intend to use the unique nature of this new invention to build roads. If the roads glow up on their own, Cars would have a much easier time staying on track, reducing accidents. But that is not the only application of this technology. The Al-Aziz Mosque in Abu Dhabi utilizes a similar concept. Lights have been placed behind the calligraphy on the mosque to make it light up in the dark, adding another dimension to its beauty. Light-emitting concrete is an interesting tech that, once perfected, may be in every home. 3D knitted formwork. Developed by ETH Zurich in Switzerland, 3D knitted formwork is a relatively new concept designed for creating complex warped concrete structures with ease. The process starts with an industrial knitting machine that creates a double-layered cloth in the exact dimensions needed to create the structure. This cloth is then stretched and formed into the shape of the planned structure using ropes and a boundary frame. And that pretty much finishes up the mold. Next, cement is sprayed on top of the outer layer, thick enough to provide support, but also thin enough that it does not weigh too much. Once the cement has dried, the structure is finished. No bricks or cement blocks needed. The boundary frame and supporting ropes are removed, and the structure is able to stand on its own. And not just that, this construction method has also proven to be very sturdy. Knit Candela, made in Mexico using this construction technique, was built with knitted cloth that weighed just 55 pounds. And once the construction was finished, the structure weighed a total of 5 tons, completely freestanding, requiring no support. Aside from being sturdy, this construction method also provides another advantage. Since there are no rigid molds involved, the builders can create steep curves and waves easily using 3D knitted formwork. Moving on, we have a new kind of insulation method that even NASA is using. Aerogel insulation. Aerogel is a new kind of material that seems magical if you don't know the science behind it. This American-made material is developed using the best insulating material in the world. Just how good is its insulation? Well, you can light a fire right underneath a thin sheet of this material, and it wouldn't even melt a piece of chocolate placed on top. Those are some insane levels of insulation. And that makes sense since this same substance is used by NASA to protect their spaceships and in spacesuits. On top of that, aerogel is an extremely light substance. If you held it in your hands, you would barely even feel it. And that's where its application in construction comes in. Aerogels are now being used to insulate homes, providing performance that you cannot find in any other material. Not only that, but it is being used as a noise cancellation agent, reducing noise in homes. But the surprises don't stop there. Since aerogel is so efficient at what it does, you only need a thin layer of it to get the same results you would get with a much thicker insulation layer made of another material. This means that insulating with this material requires much less space, maximizing the available area for use in a home. Top-down construction. Usually, when a building is being constructed, they first start with the underground floors, working their way upwards. But a construction technique developed in America turns that tried and tested theory on its head. Known as top-down construction, this technique involves building both up and down simultaneously. Here is how it works. The workers start by first building the above-ground part of the building. At the same time, excavation work begins below, creating the basement levels one by one. As the building rises upwards, so does it extend downwards. But how is it all held up? The answer lies in the step-by-step process of the excavation. Each basement level that is dug out provides support for the rest of the structure. The basement slabs act as the bracing for the retaining walls, bearing the load. And each time a new basement level is dug out, the load shifts to that new level. This process is repeated over and over again until the entire structure is finished. There are a couple of reasons why this technique is becoming popular, especially in urban centers. First of all, it saves time, and the building is being constructed twice as fast. Secondly, there is much less soil movement, which can be a hassle to manage in bustling urban areas. Floating foundations for wind turbines. Experts from the United Kingdom and Japan have figured out a new way of installing wind turbines out in the ocean. While traditionally wind turbines are installed on a base that extends deep into the ocean to the ocean bed, a new method has been introduced that actually makes the turbine float. Not like a boat, however. The method used is more similar to how oil rigs float in the ocean. This method requires a semi-submersible or fully submersible base that helps the turbine stay upright and stable in the ocean currents. The base isn't free-floating, though. It is anchored to the seabed using strong lines so it doesn't float off. But the question is, why do we need these? Well, the world is moving towards green energy at a fast rate, and that means countries require more and more space to install wind turbines. However, the shallower parts of the oceans aren't always the best place for that due to terrain or weather problems. So when a wind farm needs to be built on deeper sections of the sea, these kinds of designs are a lifesaver. Floating foundations are a big step toward making wind farms a more viable solution for green energy. Algae facades. Construction companies in Germany have figured out a more environmentally friendly use of building facades, and what it does is insane. Companies like SolarLeaf are developing facades that have algae growing inside them. By placing small colonies of algae inside the glass and filling it with water and a little bit of carbon dioxide, they are able to make the algae grow like crazy. But this isn't just to give the windows a green tint. These algae are actually super useful. They absorb the sunlight and, in turn, produce heat, which can be recycled to heat up a building. Additionally, as these algae grow, they can be harvested as biofuel to produce clean energy. But the surprises don't stop there. The algae's growth can be monitored and managed depending on the season. In summer, it can be allowed to grow thicker, so less heat and sunlight get into the building. And in winter, the opposite can be managed by reducing the algae growth and harvesting the surplus. It's like nature's own curtains. Not to mention how cool the building looks from the outside and inside. Algae facades are a cool new concept that merges natural architecture with environmental friendliness and practicality. The Biointelligent Quotient, BIQ, house has already utilized this tech, and judging by its benefits, more and more buildings are expected to pick up the trend in the near future. Even crazier is the next one, where builds actually heal cracks, all on their own. Self-healing concrete. The Netherlands has created a new type of concrete that can mend itself after cracking without losing strength or toughness, and how it works is fascinating. Basically, this new type of concrete is made with a bunch of bacteria thrown into the mix, and they are the workers who fix any crack that appears. The process is quite simple. When a crack appears, bacteria produce calcium carbonate, also known as limestone. This limestone then fills in the cracks, filling in every pore. It takes some time, but soon enough, the crack is completely filled with the white substance, bonding the two sides together with a naturally forming agent. A rather environmentally friendly solution. But what are the benefits? Well, self-healing cement could be crucial for building structures that aren't monitored enough for damage, yet play a crucial role, like bridges or remote shelters. Additionally, it will also be a great component for automatically fixing cracks in hard-to-reach places, like the outer walls of a skyscraper. Amphibious foundations. In areas where floods are a constant threat, like Louisiana, Builders have come up with a unique way to handle things. Instead of building homes with a fixed base attached to them, they have started utilizing amphibious foundations. These foundations are designed to float on water, carrying the house with them. So when the flood happens, the house simply floats above it, instead of getting submerged. And to ensure the structure doesn't shift from its position and settles down in the correct spot once the flood is over, these amphibious foundations are anchored in place. This invention can be a lifesaver for people who live in flood-prone areas, ensuring the residents have shelter even during the worst of times until help arrives. Autonomous construction machines. Turns out, you don't even need humans to build houses anymore. Construction companies have developed robots that get the job done all on their own. Each one of these is made to specialize in one specific part of the construction process. There are robots designed to lay down bricks, others that pour in cement, and even ones for leveling out the cement. Then there are the window installer robots and even autonomous construction vehicles that can build roads all on their own. The robots really are taking over the construction industry. And well, there is a good reason why. These robots don't need rest. They can work pretty much 24/7. They are also more efficient, requiring less time to get the same amount of work done. Plus, they don't make mistakes. For construction companies, that's a pretty great deal. However, there is another new invention that is even more efficient while also being autonomous. 3D concrete printing. While robots are fast, they cannot compare to the speed at which these 3D printers construct houses. By laying down concrete layer by layer, these beasts can shape up a home in just a matter of days, or in some cases, just a few hours. The cement used in the process is quick drying, so by the time one layer is laid down, and the nozzle has made one full turn over the emerging structure, the lower layers have already solidified, ready to be built upon. The printer itself is very large in scale, and that's necessary since it has to construct even larger structures. But there isn't a person operating it. Rather, a set of commands is inserted into the printer beforehand. It simply follows them until the structure rises into shape and is completed. Buildings made this way are surprisingly durable, and more importantly, they are precise. Not a thing out of place. Every layer is placed down perfectly, creating a mesmerizing pattern. But even though this construction method is gaining popularity and is certainly quite fast, does it really compare to the beauty of this next technique from ancient times? Earth berming. Earth berming is a construction technique that has been around for as long as humans have been building homes, and even today, it has not gone out of trend. The concept is incredibly simple, yet gorgeous when implemented. A site is excavated before the construction of the home begins. Once the ground is leveled, a strong structure is built capable of handling heavy loads using supports. Once the house is built, mud and soil are piled on top, covering the structure in its entirety, only leaving openings for doors and windows. And just like that, one of the most ingenious construction methods has been implemented. The benefits of this construction technique are insane. The soil acts as a noise-canceling insulator, providing quiet and peace inside. But more importantly, it keeps the house perfectly insulated against the varying temperatures outside. Even in the hottest of summers, the house stays relatively cool, like a cave. And during those cold winters, the mud and soil help retain heat like no other insulator. The standout feature has to be the beauty, however. Once vegetation grows, the house looks like it came right out of the Lord of the Rings Shire. The synergy with nature is as relaxing as it gets. Despite being ancient in origins, the earth berming construction method has stayed one of the coolest even in the modern world. But if you need to build homes fast and with ease, this next construction technique is more suitable. Precast modular construction. Who would have thought houses could be put together like Legos? And not just houses, skyscrapers too. A technology called precast modular construction, developed by Sweden, the United Kingdom, and Denmark, has made this dream come true. This method involves creating components of a building, like walls, windows, and roofs, separately in a factory beforehand. Then, these parts are taken to the construction site, where they are put together in a matter of hours. The modular components have design features that allow them to interlock with each other or be connected using specialized parts. The whole house can be assembled this way, and surprisingly, it is just as durable as a traditionally built structure. The only issue is how fast the construction process is. A whole skyscraper can be built in just a few days, and a bunch of houses can be assembled in hours. At the same time, this construction technique does not require a lot of workers. Just a few personnel can assemble a modular structure easily. Not only that, but this method also reduces waste, as everything is built efficiently in a factory. And there is no real downside. Modular construction is the perfect evolution of construction methods. Which construction technique do you think is the most impactful? Let me know your thoughts in the comments down below. I would love to hear your thoughts.